Well, thank you. So we put on lectures first Wednesday of the month all year long. And tonight we actually had scheduled a different speaker and he couldn't make it. So I'm filling in. And the program you're going to see tonight, we had just enough time to get the word out. This program I put on for Ollie, Osher Lifelong Learning, in conjunction with the Bureau of Land Management. And we've got their office staff here tonight. So I was able to fill in here at the last minute. Excuse me. So there are 2 bathrooms all the way down the hallway. There's water right around the corner. Please feel free to get up at any moment and do what you need to do. And usually we ask you to hold questions until the end, but this is a pretty small group. So throw a shoe at me, raise a hand, whatever, and ask questions whenever it comes up. I think it's better that way. All right. You may have heard that there was a water problem in Trinidad over the weekend. And when I heard that on the news, I thought to myself, well, even Trinidad isn't perfect. But you gotta love Trinidad. It's got history, it's interesting, it's diverse, it's got lessons about how California was built, and it's all right there in front of you. And so I'd like to cover quite a bit of that this evening.
I'd just like to clarify that we do have water in Trinidad, which is the states, and we can't drink it.
Turbidity?
No, it's.
Is it the water going to Mill Creek?
They've been pumping water from Glendale, trucking water from McKinleyville, which is Humboldt State, community service district, which is perfectly good drinking water, but because the pipes were down there's always a residue in the pipes that
sediment, turbidity. Yeah, sorry.
So we have lots of water, we just
can't drink it. Okay. Well, how fortunate we have a few people here tonight from Trinidad. Fire district. Yeah. Okay, cool. Well, feel free to contribute here. Add anything that pops up. Okay. That's all he's got. Okay.
Okay button. So you put the recording.
I'm going to click that OK button. There we go. I don't know if you've seen the lighthouse, the real lighthouse at Trinidad Head, but there it is around the corner. And this is from a BLM brochure. The woman there is Janet Harrington, the wife of the housekeeper at the turn of the 19th to 20th century. To her right, you can see a building. That is the lightkeeper's house. Gone now, and there's a flat piece of land there. And then the bottom picture is her husband, Trivial Pursuit. Anybody know his name? Fred Harrington is standing on the lighthouse. He kept a journal every day for whatever happened in that area. And one day, I'm going to try to remember the date. It was 1913, maybe. One day he was on duty and a rogue wave smashed into the lighthouse and he spent some time repairing it. So look at that cliff and tell me if that isn't the monster of all rogue waves. Yeah, okay. So this is 300. Because of the waves in between. So it builds up because of the conformation there.
Spells so they get bigger, and then they get slammed against human head and splash up.
Yeah.
And my understanding is from Rachel Parsons.
Well, I would be impressed to be on that lighthouse.
Yeah.
Okay. So some of the topics I'm going to cover tonight are a little Yurok history, the California Coastal National Monument, which very few people have heard of in my experience, the geology of Trinidad, and trouble ahead, and I'm going to leave that a mystery until the end of the talk. A red arrow just occurred on that cliff, and I honestly don't know where on the cliff that red arrow is supposed to be. But in the year 1700, that's before I was born, in the year 1700, we got the big one, the last recorded breaking of the Cascadia subduction zone, and the entire ocean looked like it was coming ashore. Somewhere on that cliff is a marker from the tsunami. So I put the arrow there as kind of a teaser because we're going to talk about how you get tsunamis in this area. Okay, first a little introduction. You've got the original Shirai village, Trinidad the city, Trinidad Head, Peewitol Island, and Flatiron Island. Now you locals will know the names of some more islands. So what's this one?
I don't know. Blank rock.
What is it?
Blank rock.
Blank? Huh. Somebody lost their creative juices. And there's a green rock somewhere. Is that this guy?
Yeah.
Okay. All right. So a little adventure into the Yurok presence. I hope you can read this map, but as you see, oh, I've got an arrow. Hang on. There is Trinidad, and if you can make out the dotted lines there, Trinidad is sort of the southernmost village from the Yurok tribe. Mostly it extends. No, I set the alarm. I don't know what that was.
Oh, okay.
Just in case you were thinking of falling asleep. We do that. Yeah. Imagine that this is the first time you had to come into the building and set the alarm, and that sucker goes off. Oh, man. Heart attack city. Yeah. All right. Where was I? Most of the Yurok population was along the Klamath River. It's 1 mile on each side of the river, the town of Klamath. And then, and they've been there, their expression is time immemorial. It's been at least 13,000 years since folks traversed Beringia, the land that is now underwater between Russia and the United States. And then this, if you've seen this granite cross, right in the middle, I don't know if you can make it out, it says 1775. There were 2 Spanish ships that pulled up to Trinidad Head, and being Spanish, they immediately came up and sank a wooden cross into the soil and claimed this area. Now, if I was a Yurok tribesman, I'd wonder at that. They didn't cause a lot of trouble. There were 2 lost sailors who had jumped ship, and one of them was never found. So maybe he moved in with Yurok village somewhere, who knows? So that was fairly innocent. But if you know anything about California history or the United States history with Native Americans, it went downhill from this point. This is a drawing, it's called a Honeyman drawing from the 19th century. You can see a sailing ship out there and some early settlements. Trinidad was the first harbor used in this area. It was useful And people were looking for a harbor because gold was found on the Trinity River. And so this became a dropping off of supplies place. And then later on, Humboldt Bay was discovered and took up most of the population. Okay. Anybody here been to Sume Village? Okay, most of you, good. The Yurok people did not cut down redwood trees, I understand, but when one fell or was down for whatever reason, they could make planks out of it. And that made for really sturdy houses, as you can see here. This one is a sweat house. Here's a diagram of the inside. You can see there are planks on the floor. And men would gather here every day. So after a community meal, the men would gather in the sweat house. They would build a fire, they would sweat, and they would punch each other in the shoulder and tell jokes and talk about their day. And when there were Indian wars in the 19th, early 20th century, there was a president, I don't remember which president, but a president of the United States said, well, we can't get along with those Indians because they're communists. I suppose this is what they meant, that if you hang out in collective groups as part of their culture, maybe that's what somebody was referring to. I like this idea because every culture has a problem with young men. How do you get young men to participate in your culture? It doesn't seem to be a difficulty for women, but men tend to go off in their own directions. And this means a young man gets raised up and he knows who he is. He knows where he belongs. He knows the history of his people, that kind of thing. So every evening, the men would sleep in this building. Here's the community house. It's bigger. And this is where women and children sleep at night. Here's a diagram of the inside. Notice that the center of this building is dug down into a pit. If you are sleeping on a tule mat and you pull a rabbit blanket over you to stay warm, you're out of the wind. These buildings are very gappy so that the wind, especially in the winter, will come in and chill you down. But if you're down there by the fire, it's actually pretty warm. So community meals happen here. Notice that at ground level, around the edge of the pit, there are baskets. The Yurok people have more than 40 different kinds of baskets. This is a wonderful technology. They didn't do pottery, but they had baskets that were waterproof, as in you put water in it and it doesn't leak out. So you could take a hot rock from the fire and put it in there, and you can even get boiling water. You just have to keep it stirred so it doesn't burn the fibers. Community buildings. So communalism and a very close attachment to their environment. They knew all the plants, they knew what to eat, they knew how to make baskets and everything else they needed. Young men tended to be the ones trained for hunting. So to bring protein in for deer, elk, and whatever, it would generally be men. Men were also trained for specific crafts, like this guy. A Yurok tribe member would spend his apprenticeship learning how to make a canoe, and then the rest of his life, he would be the master craftsman that made them. Sometimes they would trade canoes to other tribes, and canoes aren't just transportation, they're alive. So for example, in the canoe on the right, up front are some curved structures carved in there. Those are considered to be the lungs of this canoe. It has a heart and it has kidneys. There's even a nose up front, a projection of redwood. And I thought, well, that's a good place to tie a rope around if you're going to anchor the boat on the shore. But a Yurok tribeswoman said, no, if you tied a rope on there, it would break off. So it's just a nose. It's a feature of a semi-living thing. I love that. Okay, this picture is demonstrating, I took a pano here so you could see the entire pier. It's owned by the Yurok tribe. And here's a close-up shot of the base. There's a restaurant there. I'm blanking on the name of the restaurant. Seascape, thank you. If you eat at the Seascape, I have advice for you. When you order your meal, order the pie at the same time. If you wait until after the meal, the pie could be missing and you've missed the major event of being there. I go there with tour groups during the summer, and we always give them that advice. This next feature is brand new, the Welcome Center. This past summer, they were pouring concrete, and it looks like it's getting pretty close to finished. So this coming summer, I'm looking forward to going in there and walking through the Welcome Center. Oh. Oh, good. Well, I want to go there and sample it. If you Google Native American history, you will find literally hundreds of books. These are 4 that I can recommend. American Genocide is difficult to read. It is a compilation of all of the genocides and murders and massacres that happened in California as it was becoming a state. And it's not pretty. I knew nothing about this when I moved up here. And you can understand why. It's dark. I mean, this is not a good side of humanity, but it is our story, and I think it's important to talk about it. The next one is the Rediscovery of America. That book is 400 years of treaties and broken treaties and how Native Americans influenced the United States and vice versa. Did you know, for example, that there's an association of Native American tribes in New England and like in the Ohio, the Iroquois Confederacy is one name for it. The way they organized their society influenced the Constitution of the United States. There's a federal layer of bureaucracy, and then the states and the tribes up there had been for centuries organized that way. So we learned from them too. Bury My Heart at Wounded Knee is a famous book, a history of the relationship between Americans and Native Americans. And the last one is based in California, and I found it fun because it has specific tribes throughout the book, and you can flip open to the Wiyot, which is where we are, and read about something about their culture. Okay.
Okay, one thing there's a book written by Lucy Thompson. She's local, it was around the turn of the century. It's called To the American Indian.
To the American Indian.
And she it's at the Humboldt County Library. You can order it from any library branch.
Mm-hmm.
And she married a rancher up in Ball Hills. And so it was very much a bicultural family. They lived in Eureka at one point. And so she tried to write the story. He helped her with from English to get the story written. So it wasn't perfect English. But you can get you can get that book from the library.
Okay.
And she tells lots of stories about the Iraq and the Children and people.
Okay. And what was the time that they lived? 19th century?
19th century.
Yeah, early on. Okay.
Yeah.
All right.
1919.
Thank you. Say the name again.
To the American Indian.
To the American Indian.
She's afraid that their history would be lost.
Uh-huh.
The stories would be gone, and that's why she wrote it.
Yeah.
And so there's a lot of stories. She even includes some from the Hoopah, we call Hoopah, because they were all trading with each other all the time. So
yeah,
it's really good, very local, and really personal.
I like that local focus. Okay, thank you. Okay, so we're leaving Yurok tribes behind, and we're now going to slice and dice Trinidad. Here's what I mean. Trinidad Head is owned by the Yurok tribe, except for that little icon down there at the southern tip that represents the lighthouse. Pewatole Island. Beautiful, isn't it? And these are photographs from the Bureau of Land Management. I like this one. If you've been to Trinidad lately, you know that those trees now on Pewatole Island are all dead because two young men, remember talking about two young men, climbed up there, started a fire, and killed all the trees. The fire department couldn't get there fast enough. Were you involved?
Yeah.
When was this?
The problem was BLM.
Been working here.
That was before his time. You can't blame him.
You're kidding. BLM would not allow us to put salt water on. We had to use fresh water to put the fire out.
Oh, so you had to pump
We
it.
had a helicopter that could dip the water right out of the ocean and extinguish the fire, but they wouldn't let us do it. So they had brought the helicopter in, and they brought, at that time, the quarry has a big pool in it from where they blasted out the rock. And they were flying back and forth to get that water out of there. And after about 6 trips, they couldn't do it anymore because the water level was down so low.
I'll be
But yet
darned.
we have all this, and the reason that is so discouraged, of all the words I can think of, is because Pewatole has blowhole in it. And it constantly gets
Around the,
salt. On the other side of Pewatole, there's a giant blowhole. And whenever there's a big wind or a big surf, that blowhole blows saltwater spray all the way over that rock.
So why can't they let you use the salt water?
Pardon me?
What's wrong with using salt water? Plants, the plants on
They said we killed the plants,
yeah.
but then the fire killed everything.
Yeah. I hope the people online could hear some of that story. The man who personally got up there and tried to save that fire, the fire department, the story was that the BLM restricted firefighting to fresh water. And so they ran out of fresh water and couldn't stop the fire in time to save those trees and other plants. Even though there's a blowhole on the other side and prevailing winds will
bring salt water there.
Will spray salt water up there anyway. Yeah. Oh, well.
There's also a living tree on
Oh, there's still one? Ah.
on the college coast.
Is it a spruce?
Yeah.
Ah, I'm gonna go up and look for it. Okay. We're told that there is actually still a living Sitka spruce up there. Could everybody here spot a Sitka spruce? See the bark on this tree, how it looks like puzzles or potato chips, I've heard it called. That's a giveaway that you're looking at a Sitka spruce. They are salt tolerant, especially relative to redwoods. Our coastal redwoods don't like salt spray, and so you won't find them as close to the ocean as these spruce trees grow.
One of the really easy ways to spot them. I've worked with kids for years is to find the cones on the ground. The cones are soft.
Yes.
But the leaves are sticky.
Yeah, very good. The cones are a giveaway. Yeah. All right, here is Flatiron Island, and you can see a boat there in front for scale. Somebody went through a lot of trouble to paint this rock white.
Yeah.
And we now know who that is. It's these guys. It's the common murres. These are ocean-going birds. They spend 90% of their lives out on the water diving for fish, and they only come here. That's not our alarm, is it? Okay. I'm paranoid now. So the common murres, look at how many of them are on this Flatiron rock. That's not true today, and you're going to learn why.
Used to be many years ago, I won't say how many because I'm not person. But it used to be that Flatiron Rock was a sea lion rookery. And we don't have sea lions at all around Trinidad anymore.
Yeah.
And it was so loud that you couldn't go sleep at night without hearing the barking.
The barking. Well, I'm going to talk about what happened to those sea lions. Ah, I just took a class there. They talked about it a bit. Yeah. No. All right. So here's a common murre nesting on Flatiron Rock. And notice there's nothing to stop that egg from rolling into the water. So these very clever birds designed an egg that's very pointy. And if it rolls at all, it's going to roll in a tight circle and not go off the edge into the water. I mean, round of applause to these clever little birds. Okay, so we're slicing and dicing Trinidad, and this is a key point here. I hope it's all visible. You're looking at the coast of California, and that red line represents 20,000 islands and sea stacks up and down the coast of California. That is the coastal monument, the California Coastal National Monument. It was President Clinton, so whatever year that was in the
2000.
2000 it was created. Thank you. All right, so 20,000 islands, but the definition is going to get narrower here. Stay with me. 20,000 islands, a 12-mile zone. So that gray line outside the coast represents 12 miles offshore. Here's Trinidad, and Trinidad is one of 6 CCNM parcels that come up on land. And I've already said that the lighthouse on Trinidad Head is property of BLM. That's why. I don't know the details on the others, but the arrow is pointing here to Trinidad Head. You can also see some red representing the various islands and sea stacks. So what is the definition for a national monument? It involves this chart. You can see the coast here, and the dotted lines are all offshore, right? So you see the continental slope that goes down into the ocean deeper and deeper. The sections that are closer to the land tend to be California jurisdiction. And then when you get out to the last dotted lines away from shore, we're in federal territory, like Coast Guard and so on. So the California Coastal Commission has a lot to say about right there at the water line and on land. And then you get to CCNM and so on. So I find this interesting that this national monument that we see every time we drive past Trinidad is the part of the islands that sticks up above the mean high tide line. So the shaded area there, that's part of the national monument. The underwater parts might be part of a marine reserve or some other monument, but it's a different jurisdiction. I have no idea. You might know. Why this? We'd have.
That's the way that Congress approved. Congress signed the law.
Congress did it. All right. So we'd have to talk to Bill Clinton, maybe. All right. So the portions that we're talking about today largely are this CCNM, and they're under the aegis of Bureau of Land Management. Okay, let's move on to geology. And here's where the cookie comes in. I hope you're staying awake over there. Trinidad has, like all of California's coast, has a tortured past. If you recognize this map, you'll know it's from the Clark Museum. I've stood there and stared at that map quite a bit. The tan areas represent where you find coastal redwoods. The dark green is Douglas fir and so on. And it's a scale map. It was put together, created for, what was that, 1915 exposition in San Francisco, something like that. But the part that I want to talk about is, why are those mountains all lined up in the same direction like that? It's like a bunch of caterpillars all crawling up in the same direction. Well, I'd like to explain why that is so. And to do that, we have to go to the bottom line, which is plate tectonics. Now, you may know that in the 1930s, a guy named Wegener came up with this idea. And he was fond of saying, you look at a map like this, and doesn't it look like South America could fit right into Africa and so on? Well, he came up with a theory to explain it, and everybody laughed at him, and he was sort of debunked, and they wanted to kick him out of the scientific community until evidence came in. And some of that evidence involved, look at the middle of the Atlantic Ocean. This picture is about earthquakes, and every one of these little dots is an earthquake. The different colors represent different magnitudes, right? So you look at this map, and it's pretty clear that the earthquakes happen in a very coordinated way. Why is there a whole string of them running right down the middle of the Atlantic Ocean? Well, in the 20th century, we sent ships across the ocean, dragging all kinds of instruments. We now know what's at the bottom of the ocean. And those dots, those earthquake signals represent a mountain range at the bottom of the ocean. And I'm going to go into more specifics about how that works. But because of that mountain range, new lava is coming up all the time, and it's pushing the floor of the ocean apart. That's what happened. We used to be joined up with Africa and Eurasia, but 200 million years ago, this happened. It's called a mid-Atlantic ridge, and it's one example of spreading centers that you'll find all over the world. So that new lava coming out forces the seafloor to spread apart. So why do we care? I mean, what's this got to do with Trinidad? Well, here it is. All of North America is being pushed west. So you have to remember that. North America wants to be friendly with Japan, so we're headed that way. And that's going to matter because we've got something pushing the other way here in a minute. Of how a spreading center works. So notice the red blob there that says magma. The rocks under the crust of the earth are kind of like taffy. They're not melted, they're not solid, they're sort of in between. So over long periods of time, they flow. And when you get a glob of it like that, it tends to pop up in a ridge like that. So this is new lava coming up. And as it creates new rock, it gets higher and higher. And then the mass of it, the weight starts to push down and it collapses. And that's what forces the ocean floor to split. Like that. Notice at the top of this picture is the island country of Iceland. It's an independent country until we send our military in. I'm sorry, I had to say that. And interestingly, right in the middle of their country is this valley. So one part of Iceland is on the North American plate. The opposite part is part of Eurasia. So they're very much an international country. This is the problem. This is an image, if you were in a satellite 100 million years ago, that blue blob there is called the Farallon Plate. It is the floor of the ocean, floor of the Pacific Ocean, and the left side of it is a spreading center. The problem with that is that that chunk of ocean floor is moving east. So now you have the picture, North America moving west, ocean floor moving east. Something's got to give. And so now we're going to zoom in closer. So this is home, right? There's our spreading center. And what do you suppose happens when the Farallon Plate, here, see the words Cascadia subduction zone? Well, let me get out my pointer. If you look at the bottom of this diagram, here's the spreading center. This is new rock emerging. It's pushing this ocean floor into a collision with North America. And look what happens. The ocean floor dives down. That's called a subduction zone, and that's where you chose to live. Subduction. Okay. We've now arrived at, this is another satellite view, okay? And what makes us famous? Can you see Eureka there on the right? What makes us famous to geologists around the world is that red arrow, Mendocino triple junction. So in order to figure out why the area you live in is so complicated, I found that the only way to get to the bottom of it is with cookies. So please get your cookies out. So not only is this a teaching method, but it's your reward for the hard work that you're going to put in here. Okay, don't do anything yet. I'm going to walk you through this. Triple junction means that major cracks in the surface of the earth, 3 of them have come together where we are. And they're all doing different things, and only the cookie knows. Okay, so we're going to use cookies. And the first thing you want to do is take one part of the cookie and see if you can pull it off so that it does this. Only one side has filling and the other side is just cookie. If you failed at that, you have to get another cookie. Were we successful? Oh, great. Okay. Now set down the part with the filling, and the part that's clean, break it exactly in half.
Exactly.
Yeah, as close as you can get. It went its own way? How close? 3 parts? Okay, you should start with another. That's good. You can still work it down. Okay. Out in the ocean, so 30 to 50 miles away from us, is a spreading center. And we're going to use your cookie to demonstrate how that works. So reassemble your cookie, put everything back together. And now the part that's on top that you broke, pull it apart like this. You got it? You just demonstrated that in the ocean floor offshore from us, a spreading center, I'm calling it. It's also known as a divergent boundary. So now look at the picture of my cookie on the screen. The left part of your cookie, the left part, represents the Pacific Ocean plate. The right part of your cookie represents this thing called Juan de Fuca plate. That is the plate that's crashing into North America. What's separating those 2 plates is this spreading center in the middle. All right, so what is the white stuff? In your case, the red stuff. What's the red stuff?
Magma.
Magma, new rocks, melted down there. Okay, so this is part 1 of the triple junction. Let's look at part 2. Put your cookie back together. And now we have a convergent boundary. So when the ocean floor crashes into North America, who gives first? Who goes under?
Oceanic.
So the ocean plate goes under North America. So now reassemble your cookie so it looks like this. The right side is at an angle and up on top of the left side. Okay, so if you look at this diagram, we're talking about this purple line, the one on the right. So now the left side of your cookie represents the Juan de Fuca plate. The right side of the cookie is North America. And if you see a tiny little crumb here at the ridge, that's you. If we could zoom in, we'd see you waving at the satellite. Okay, so this is called a convergent boundary, also known as a subduction zone. I'm going to stick with subduction zone because we're going to go into more detail here. Okay, yeah.
Landslide and subduction. 1 centimeter a year.
1 centimeter a year. Yeah. I heard a geologist one time explain it with her hand like this. When the ocean floor ducks under, see how my fingers are bending? The shoreline builds up tension like this. And then, let's say January of the year 1700, it all gives way at once. And that lifts up the ocean water above it, which wants to come back down and flood and destroy everything. So that's a problem. Yeah. Did I answer your question?
No.
Okay. All right. So that was part 2 of triple junction. Now let's go to the last part. What do you call a big crack in the earth coming up the coast of California? The San Andreas Fault. This is very different from the 2 parts that we just looked at. Now, I want to point something out here. The San Andreas Fault comes up the coast of California, and then it takes a left turn and heads out into the ocean. Can you see this crack in the ocean here? That is the Mendocino Fault, but both the Mendocino Fault and the San Andreas Fault are doing the same thing. So put your cookie back together, reassemble cookie, and now the right side of the cookie, you want to pull that closer to you. You're separating them in a different way now. It should look like this. So now this is a different kind of fault. I don't really want to go into more detail about it, but the reason there's a San Andreas Fault goes back 30 million years. The entire coast of California at one time was all a subduction zone. But remember, North America is moving west. It ran over the subduction zone. It started in what is now Los Angeles. North America ran over that subduction zone and it disappeared and became this transformed fault that we call the San Andreas Fault. Okay. There's some new research that says, I hesitate to say this, they're linked. In other words, when the San Andreas Fault goes in a big one, it could very well stimulate the subduction zone where we are to do its thing. So we used to think that from Eureka north was someday going to have a very bad day. Well, now it's all of us. It could, if this research is correct, all of California and Oregon and Washington and Canada. I mean, this thing is 700 miles long. All of it is going to go at once in the worst case. All right, so don't eat your cookie yet. We have one more thing to do with it. This diagram is from Lori Dengler, and we're very lucky up here to have a geologist who is not only good at what she does, but she's a good communicator. And so this is one of her diagrams. What you're looking at is, well, let me put Eureka there just for orientation. That yellow circle is triple junction. And once again, the polka dots are earthquakes. So this diagram is showing that there's a cluster of earthquakes right at triple junction, and for good reason. If the earth was a living thing, this would be a boil on its skin. I'm just making this up. This is an irritation to planet Earth. You've got three plates crashing together, all going in different directions. No wonder you have earthquakes out the wazoo. But we're not the worst in the world by far. Okay, see those black arrows? That is demonstrating that the Mendocino Fault, which is a continuation of the San Andreas Fault, The Mendocino Fault is a right lateral fault. So let's say you're standing on that arrow at the bottom, looking across the crack in the earth, the other side is moving to the right. Okay, so now get your surfboard out and you're going to paddle up to the top black arrow. When you're looking south, the other side is going to the right. So no matter which side you're on, the other side is going to the right. This is called a right lateral fault for obvious reasons. There's an orange circle there that has 7.0 there. That was December of 2024. We had a big one, an earthquake. It didn't seem to do a lot of damage, but that's Mother Earth just reminding us that she has her own opinion about how things work. Oh, and I just put a note for myself up there. This can cause tsunamis. All right, so this is the public service portion of the talk tonight. What should we do? And when I was asked this question years ago, I said, well, you want to stand in a doorway because it's structurally stronger. And Lori Dengler says, no, that's not the current thinking. When an earthquake happens, look at the top panel of this diagram. You may not have a choice. If it's the big one, the ground is doing this and you can't stand up, right? And it could go on for several minutes. The idea here is drop and cover your head because pieces of the ceiling are going to fall on you. If you can get under a table, something like that. She said, just drop beside your bed if this is the middle of the night. Anything that can protect you from falling structure from the building you're in. Okay, so you've lived, you survived the earthquake. Now what? Get to high ground, the middle panel here. And the reason for that is when a tsunami comes ashore, a tsunami that just reaches as high as halfway up your shin will knock you over. There's a lot of force in the water. But now imagine water that's over your head and it's carrying cars and trees and houses. This is like a very rough sandpaper. It will clean out the landscape, but this is nasty business. And if you've seen, we have local maps in this area for where the tsunami zone is. You should always be thinking about where you are and where to go. Okay, we're in the tsunami zone right now. So pop quiz, you've got 2 minutes to save your life. Where would you go? Where? Go to Wildberries if you can get up there. Your survival strategy could very well be a beer. Yeah. Pickle Hill. Well, if it was me right now and I had to decide, I'm going to go to Mount Trashmore.
Oh, yeah.
It's right around the corner. It's the highest ground here at the Arcata Marsh. It used to be a former dump. They formed Clop Lake by scraping mud and putting it on top of the dump. So it's the highest ground in this area. It still might not be high enough, but you've only got a couple minutes. Remember, that spreading center is just right offshore. This is a mess. We had a test, not this past December, but the year before. That's when we got that 7.0 magnitude earthquake. An emergency signal went out. Evacuate Eureka. Anybody know what happened? It was a nightmare. Traffic jam. So the thinking is now, okay, we learned from that one. It turned out it wasn't an emergency, but you didn't know that at the time. Don't get in your car because everybody around you is getting in a car. You're going to be stuck in a parking lot watching the ocean come on shore. You're going to, yeah, it's dangerous. Okay.
When that happened, we got to call fire department to evacuate the lower sections, State Beach and all those. And we did that, and I drove the fire engine down and I blocked the Edward Street going down to the Marine Lab and down to the boat on the beach. And we went down and evacuated everybody off the beach, got everybody out 2 houses down. And about 20 minutes later, I had the fire engine blocking the road. And all of a sudden, here comes this car driving around the fire engine, trying to get around the fire engine. And I,
Like, what
and
the
I
fire engine?
I said, can I help you? And the guy said, where are you? I said, where are you going? He said, I'm going to the beach to see the sun.
Oh, no. Oh, no.
And what I wanted to say is, oh, please, go right ahead.
Yeah. But you're a professional, so. Yeah, that's an interesting story. I've never heard a local one, but I remember a story from the Great Alaska earthquake. This was like closer to a 9, which is incredible. And people around Glacier Bay up by Alaska came down to the shore because all of a sudden you could see the floor of the ocean. You could see old trees and dead animals. If you can see the bottom of the ocean, it's bad because the ocean is going to come back and it's angry. Yeah. So that didn't work out well. Huh? In Crescent City. It tends to happen all around the world because we wouldn't be here if we weren't curious, right? So we want to know. Well, this is the only chance to see the floor of the ocean. So the answer to that is education. Now you know that the ocean is coming back. Don't go there. And you can see in the last panel on the screen that you want to stay there. In 2004, the great tsunami down in Indonesia, that sucker sent a tsunami all the way around the world, and then it came back and went around again. 3, 4, 5 times these waves went around. Of course, they got smaller each time, but this is a lesson. Think of ripples in a pond. It isn't just one ripple, it's a series coming in, and you could think you're safe and go down and get wiped out. Okay, that's our public service portion. This is a diagram closer to home. Notice the shoreline there of North America. And now look at where it says Juan de Fuca Plate. And also notice it's broken into 3 parts. Now, instead of one name, Juan de Fuca Plate, we've got the Explorer Plate up north and the Gorda Plate down south. You could also call it the Farallon Plate, the ancestor of this whole plate. Well, don't worry about the names. Call it whatever you want. But remember this picture that there is a floor of the ocean approaching us. Okay, now look at that red box. I'm going to magnify that to this picture. And now you can see Eureka and the bay. And you can see these shark tooth lines that are showing that there are 2 major fault zones that dictate our environment. This is the Little Salmon River fault zone, and up above the bay going toward Trinidad is the Mad River fault zone. Okay, there's a red box around it. I'm going to zoom in, but first remind yourself about Triple Junction, because look down there at Cape Mendocino and you can see those fault lines all coming together at Petrolia. Okay, so finally here we are ending up back at Trinidad. And remember that the fault zone above the bay is called the Mad River Fault Zone, but now you can see it's not one crack in the earth, it's a whole series of them. And that tends to be true around the world. The San Andreas Fault, for example, isn't one crack in the earth, it's a series of them. So if you lived in Oakland and you're worried about the Hayward Fault, it's part of the San Andreas Fault system. Okay, so now finally we're at subduction, and it's time to go into a little more detail. I love this stuff. I hope this is interesting to you, but I really wanted to know for myself how this works. So I'm going to go into a little more detail. To explain this diagram, that big green bar you see that's bent in the middle, that is the floor of the ocean. So that is the, think of the Cascadia subduction zone or Juan de Fuca Plate, and you can see it's diving under North America. So here it is. You ready? Yeah, that's the direction it's going. that is the major part of our dynamic here in California. But I'm also going to have to explain to you what those orange bubbles are on the right side, what that other green block is just under the ocean, and how does any of that have to do with, oh, can I move this? No. All right, what you can't see is it says the Cascadia volcanic arc, okay? So up here on the surface of the land where my cursor is, that's where volcanoes are. So how does this whole system work? The best explanation involves rocks. Oops, go back. I lost my peridotite. Okay. The floor of the ocean is primarily made of a dark rock. Here's a picture of it. It's called peridotite. It's dense. It's really heavy. That's why the ocean floor is diving under North America, because believe it or not, all the continents of Earth are less dense and they're floating on the surface of these heavier rocks. Is that mind-boggling? There's a name for it. It's called isostasy. Okay, so the floor of the ocean is primarily made up of peridotite, this very dark rock. And now notice something else here. Can you see a lighter green bar on top of the peridotite? Something is happening. Cut it out, you guys. Wait a minute. Okay, there's peridotite. This is peridotite that's been changed. As the rock dives under North America, the heat increases, and of course the pressure increases because all that land above it. So heat and pressure and something dynamic happens to that peridotite. It takes in water. See that green rock up there? Serpentinite is the state rock of California. It's because of this explanation. Peridotite takes in water, so it's a hydrated rock, right? And the next step is that it keeps moving. As this serpentinite goes deeper into the earth, it gets hotter and more pressure until this happens. It reaches 500 degrees Celsius. Now, 100 degrees Celsius is boiling water. So this is 5 times as hot as boiling water, and boiling water can scald you, as you know. It can't be liquid because of the pressure. It wants to be. It wants to turn to steam, but it can't because of the pressure. So now the serpentinite is giving up its water, which is superheated, and it's so hot that it melts the rocks around it. It's melting other rocks. You see those orange bubbles? That's what those orange bubbles are. Melted rocks. And because they're melted, they're less dense and they flow up through the surrounding rocks. They're headed to the surface. This happened to the Sierra Nevada mountains, and those melted rocks stayed underground for 100 million years. And that gave them time to form these crystals. See the picture in the upper right? So the white crystals are feldspar. There's 2 different kinds. The dark peppery things are mica, and the almost transparent parts are quartz. Now here in California, we love to see quartz in granite. Anybody know why? That's where the gold comes up. When the quartz rises up through these rocks, it tends to carry gold with it, and that's what started our downward slide.
The basis for serpentine soils?
Yes.
Yeah, very middle.
Right. And when it forms serpentine soils, what matters to the living things up here on the surface of the earth is that it's poor nutrients. In other words, it's not giving plants what they want, and it's got toxic heavy metals. So it's like a double punch.
Set of plants that have adapted.
That's it. Yeah, very good. There are plant communities that have adapted to living in serpentine soils, but a lot of plants won't survive there.
But that's what that, not get pushed down into the bed. It got scraped off on the accretionary waves.
Hey, you get to come up here and do that. That's right. Okay, so if the melted rocks stay underground, they crystallize, and you see granite like this all over California. The Sierra Nevada mountains, if you've been to Yosemite, what you're looking at is granite that was underground for millions of years and formed these crystals. Sometimes they make it to the surface, right? And then you get lava. Now, lava and granite are the same rock, but lava came out into the air and it solidified so quickly that the minerals could not move and form those crystals. So thanks to our friends from Hawaii, there are two different kinds of lava. If you're walking on it in bare feet and you say, that's the broken up kind there. If it's smooth and ropey looking like the upper right in that photograph, it's called pahoehoe. So thank your friends in Hawaii for naming that. Okay, now you've got the story of a subduction zone, and there's only one piece left to do. Would you say that magic word again? What did you call it?
Accretionary wedge.
Accretionary wedge. Can you see that green thing at the top? And it's labeled accretionary wedge. So it turns out that as the ocean floor is diving under us, think of North America as scraping the surface of the ocean floor, and it's just a bunch of loose rocks. It's not igneous, it's not melted rocks like those other things we were talking about. This is just junk. It's all loose. And the reason we care about that is those are the mountains on the coast of California. So you're ready now for the last cookie episode. So reassemble your cookie, please. You ate it?
I thought we were done.
Listen, I don't want to take these home. So at the end of this talk, fill your pockets with those cookies. Okay. So what we need to explain is, where did the coastal mountains of California come from? And what you want to do now is take the two cookie halves and squeeze them together so that you want some of the filling to emerge on the top, and the filling has to be on the right side. All right, have you got it? Okay, now you get to explain to me, what is the left side of your cookie?
That's wonderful.
Yeah.
Oh, we're talking.
Seafloor.
Yeah.
Oh.
So this is the ocean plate. Well, then what's the right side? North America and the goop? Yeah. This is the loose rocks on the coast of California, and that explains a lot. If you've ever tried to drive to Crescent City, did you notice that there were delays in traffic? That's because these coastal roads are falling apart. Hillsides absorb as much water as they can, and then they slump. They start falling apart. It's all over California, and it's because we built our coastal mountains from this very loose aggregation of mixed up different kinds of rocks. Yes, it's the Franciscan Formation. Thank you.
Or we call it scenic drive.
Scenic drive, yeah. Okay, so after I've tortured you with all this information, now we get to put it to work. Can you see any of that when you're in Trinidad? And of course, the answer is yes. This is a review. This is the floor of the ocean. represented here. You see a big magma chamber? That's melted rock. And what do you call it up at the top when that melted rock emerges? A mid-ocean ridge or a spreading center. Yeah. So you might be interested to know that all over the world, the ocean floor is built the same way. No matter where you are, you could be in Indonesia, take a slice through the ocean floor, and you could identify the layers. Well, that's what I'm going to do because I have a magic sword, and I'm going to cut through the ocean floor right there, and then use it to explain what you see in Trinidad. Now, the top layer there is dirt. Okay, let's call it sediment. Sediment that came in from rivers and was deposited on the ocean floor. It could be animals that died. It's all the stuff that's in the ocean. If you've seen those documentaries, they call it snow. Little tiny particles that are constantly drifting down and builds up as sediment. Well, if you're walking down Trinidad State Beach, look at this. There's psychedelic rock. It's a kind of rock called chert. And in this case, it started out as a pure substance and it got chemically altered down there with all that heat and confusion. And it's made out of microscopic creatures called radiolarians. These creatures are so beautiful. I find wonder. I mean, if you've ever looked in a microscope at it, it's just incredible. Look how symmetrical and spiky and such a variety of different shapes. Those are all different species.
Psychedelic?
It's psychedelic. When these animals die and fall to the ocean floor, all that remains is their shell, which is made of silica. Think of a glass shell. And when you compress those over millions of years and squeeze it and heat it, doing that. The city just changed that alarm so that it came on and off automatically. We really appreciate that. Okay, well, are you impressed? That's pretty loud. You're more impressed with radiolarians. You're my kind of people. No, it's for the middle of the night when somebody wants to come in and explore. We've had computers stolen. There used to be a nice telescope right here at the window. Things walk off. It could happen during the daytime, but you need an alarm. Okay, remember that the name of this rock is chert, and it's formed from the bodies of these glass-shelled organisms. This is a different kind of chert. It's called ribbon chert. You can see the layering there. It just didn't have the chemical alteration down there at the bottom of the ocean, but it's made of the same stuff. Okay, those rocks were made from sediment, the top layer of the ocean floor. Now we're going to talk about pillow basalt.
Laytonville. It's above the, you can see the basalt on the land as you drive down 101 through Laytonville. You can see the.
I don't think I've ever noticed. I'm going to look at Laytonville next time I drive down there. Okay. Well, so the next question might be, why is it called pillow basalt? Well, here's why. This is pillow basalt on Trinidad State Beach. And I'm going to zoom in now. The little rounded shapes you see that are about the size of my hat, those are pillows. What's happening here is that melted rocks are emerging from the ocean floor. And when they hit the water, they solidify into rock. And so they tend to form these small bubbles that look like pillows to some geologists. And so they're called pillow basalt. They start out black because remember, peridotite is a black rock, but there's a lot of chemistry going on down there, heat and chemistry, chlorides, all kinds of cool stuff, and it changes the color. So this is called greenstone, but it's chemically altered basalt, pillow basalt.
If I'm not mistaken, the western side of the Trinity Alps, the Trinities are the greenstone.
Yeah, you guys don't need me at all.
Oh, we have bits and pieces of things.
Yeah, okay. All right, in this picture, we're standing on Trinidad Head, looking at Trinidad State Beach. And now I'm going to zoom in a little bit. And right back there, you can see more than one example. There are 5 or 6 rocks of chert, including the psychedelic rock, which is the most famous of them. And so you now know that that comes from the top layer of the ocean floor after it's formed into rock. This is pillow basalt, the first big rock you come to. And once you stand there and meditate on that, you'll recognize that many of those other rocks are also green basalt or pillow basalt. Okay, well, here's what you just said. I'm going to take my magic sword now and cut Trinidad Head in half. The western half is made of pillow basalt. The eastern half is the next layer down in the ocean floor. It's a rock called gabbro. It's also, its components, it's made of the same minerals as basalt, but it's hotter, and the first minerals that crystallize under this tremendous heat is a little green crystal called olivine. And so gabbro will have olivine in it, if you're lucky. But gabbro is similar and related to pillow basalt. And so that is the eastern half of Trinidad Head. And those 2 examples explain why there is a Trinidad Head, because those are solid rock. They don't erode very well. Look at the city of Trinidad and how it's on lower ground. Those are soft sediments. Over time, those sediments are going to wash into the ocean, but Trinidad Head will still be there because it's... I don't know how Trinidad Head actually got there, but you know that it was formed from the ocean floor. You know it's part of a subduction zone. Slowly would be a good answer, yeah. All right, so we're walking farther down the beach now, and you see the grandmother rock. And if you've seen it, it's striking, isn't it? It does look like a woman who's sitting there meditating on the ocean. And this picture was taken when Pewatoli still had its trees. Well, Grandmother Rock wants you to know that her end of the beach is all sandstone, which is not ocean floor. It's sediment created from erosion, and it got pressed together to make rocks. All of the rocks down at this end of the beach are sandstone. And if you put sandstone together with those other rocks, you've got the Franciscan complex all up and down the coast of California. Almost anywhere you go, if you just close your eyes and point to a rock, you could say Franciscan complex and get an A on the quiz. If you like this stuff, I love it. I was doing a talk like this one time and somebody said, "You must have read Rough Hewn Land." And I said, "What are you talking about?" This is what she was talking about. Rough Hewn Land is the story of the Western United States and where it came from. And everything I've said so far tonight is in that book. And I recommend it because not only is he a geologist, but he's a good writer, which means you don't fall asleep while you're reading it. And he has a sense of humor. He was trying to explain rock strata, and he used a picture of collapsed beer cans all stacked up on each other. And so he used those beer cans and said, this is what I mean by strata, different layers of rocks. And he says, I'm glad that I'm finished with that because all of these were horrible tasting beer. He got to go back to the good stuff. Okay, so this is the last section. How am I doing? Oh man, is it midnight yet? All right, we're now on local ecology. Okay.
Agate beach.
Yeah.
How does that? How did agates? What is an agate? You know,
Agates. The question is, how did the agates at Agate Beach get formed? They are quartz, and there are many different kinds of quartz with all kinds of different impurities and colors and so on. The kind that you can sort of see through, like translucent, are agates. And quartz is very hard. So as the land breaks up and weathers, it gets to the ocean and it gets beat up, right? And so the soft stuff wears away, and what's left are these quartz particles. They're number 4. I think it's number 7 on Mohs hardness scale. Okay. The coastline of California is actually a stair step from north to south. As you go from the ocean into the land, California is built in what are called marine terraces. So I just want to point out a couple of things about this. If you look at the water there, see where it says wave energy dissipation? That's how a flat area gets formed. In the shallow water of the ocean, the waves are beating up the rocks, sediment is coming down from the rivers, and it tends to make a flat shelf. Well, what happens next is the shoreline of California is rising. And as it rises, you get that flat shore raised up, and now you can build your house on it. The interesting thing to me is that it's like a clock. It's rising. California's shoreline is rising at a fairly steady rate. This first terrace right here, if you come down to the chart, it was made in the ocean 100,000 years ago. Well, then you go up to step number 2. It was made 200,000 years ago. Step number 3 was 300,000 years ago. So there are 6 of them, and they're all 100,000 years apart. I think that's just darned interesting. And my understanding is that the reason the land is rising, you might think it's the subduction, right? The ocean floor is pushing us up, and that has to be part of it. But we just came out of an ice age, and there were mile-high glaciers all over North America. I'm not sure how far south here on the coast they got, but ice was so heavy that it depressed the land, and it's still recovering. It's still re-emerging from the ice ages. So there are probably many factors that go into that, but it formed the terraces of California. This diagram is out of a Michael Kaufman book. He's great. Conifer Country, the Klamath Mountains. He's written and contributed to several books. I love this diagram because first of all, you can see the marine terraces of California. And now go past the drawing and look at the shoreline in the distance. Can you see the terraces? There's a flat area close to the ocean, and then it sort of goes uphill to form another. Well, these terraces have identifiable plant communities as you go from bottom to top. And what most of us want to know is, where are the redwoods? They tend to be on terrace number 2 and 3. So it's the right combination of temperature and moisture and just what the redwood trees are looking for. Here's our little town of Trinidad. Notice how flat the land is it's on. And this diagram is showing the terraces, the marine terraces of the shoreline near Trinidad. And there we are. You can see Trinidad Head just below that arrow. Okay. If you aren't nervous about the big one, it's my job here tonight to tell you about the destruction of our offshore community. This is an important diagram because people from all over the world used to come here to look at our kelp forests, a dynamic and really profuse collection of life. And it came about because of some of the factors involved in this diagram. Number one, our prevailing winds come from the northwest. So imagine a constant wind blowing up against the coast, and now you have to factor in one more thing. The earth is turning underneath it, right? It rotates. We have a 24-hour day. And because of that, the surface water moves away from the shore and out to the ocean. So far, so good. But nature abhors a vacuum. And if you remove the surface water, what happens is you get this deep water that moves up and fills that space. That's great because that deep water is packed with nutrients. And those nutrients come up to the sunlight on the surface. And now, see that little green circle? Those are phytoplankton. They're plant-like algae and diatoms and bacteria that photosynthesize. And so if you were in your satellite looking at the ocean, you see green blobs showing up all over the place. It's phytoplankton. The next step is the blue circle. Those are zooplankton. They're animal-like organisms, and their purpose is to eat the phytoplankton. So you've got the start of a food web. So you've got these little animal-like creatures eating the plant-like creatures, and then little fish come in and eat the zooplankton, and then bigger fish come in and eat them. And then before you know it, you've got whales and sharks and abundant wildlife. I mean, it's one of the wonders of the world offshore. If you've been to the aquarium at Monterey Bay, that huge tank where they actually have tidal action, keeping it moving, I love that thing. That's us. Until 2014. So this is what we're now missing offshore. This is an image from, I think this is from Monterey Bay Aquarium. You can see in the background some rocks. Anyway, look at that kelp. Fastest growing stuff on Earth. They can grow a couple feet a day. They're giants. So they're holding on to the ocean floor and they just grow up and then they just proliferate. Trouble. So I'm going to walk you through a little bit of what happened offshore. In 2011, we had a gigantic algae bloom. Now, if there's too much algae and the animal life can't eat it up, it produces domoic acid, which is toxic. And so it starts to kill things. All right, so that's a punch in the mouth. And then you've heard of climate change? Are you running for office? There is such a thing as climate change. And the part of climate change that is affecting us here tonight is that when CO2 from the air dissolves in the ocean, it forms carbonic acid. So not only is the ocean heating up, but it's acidifying. And that means creatures that want to make a shell, clams, shrimp, whatever, can't do it because acid will dissolve those shells. I'm understanding now that our coral reefs are disappearing all over the world. They're half gone now, and they're expected to all die off. What's going to replace them, and this is a page from 400 million years ago, deep in the ocean, there are coral reefs forming with silica skeletons. So it isn't going to be wipe everything out. It's just going to change the dominant creatures in the ocean. Acidity is a problem in the ocean, but that wasn't the big one. Here comes the big one. This is a false image satellite depiction of the blob. In 2014, the ocean temperature off our coast rose by 11 degrees, which is it's enormous. You just have to believe that is an enormous change. And look at this. It lasted for 3 years. So climate change. I think this is a warning to us. We're hoping that the sea life offshore recovers, but we put out more CO2 last year than any other year in history, and it keeps getting worse until we drive electric cars and put solar panels up and that kind of thing. Okay, so what happened because of this enormous temperature change in the ocean? Well, one thing that happened, look at these guys. These are sunflower sea stars. They were abundant. As you can see in this picture, they're everywhere. They're giant too. They get to be like a yard across. They have 20 to 30 arms. They are the top predator there on the ocean floor. There are slow motion images of these creatures moving along, and everything in front of them is scattering out of the way. It's like, oh my God, here comes a dragon. When these sunflower sea stars get to a sea urchin, everybody know what that is? When they get to a sea urchin, they crawl over it and they take out their stomach and wrap it around the sea urchin and digest it out of its body. They eat the whole sea urchin at once. Everybody down there is scared of these guys until they died. More than 80 to 90% of them fell apart. This is a wasting disease. You can see a picture here of one that is just bleeding out. Just last year, they discovered and finally put a name on the bacteria that's causing this. And it was so dominant, this bacteria, that it killed virtually all of these sunflower sea stars. So what, you might say? Remember that they ate the urchins? Well, what the urchins eat is kelp, and here they are munching away. If you've never seen an image of their teeth, they have 5 teeth. And so here's the mouth, right? And inside there, you can see these 5 teeth all coming together, and they'll attach themselves to that kelp and just munch through it. And now what we have, what we call an urchin baron, looks like this. There's nobody to kill the purple urchins. And so anytime an algae starts to grow, these urchins are on it. So biologists thought, well, like anything else, these urchins are going to grow old and die, right? They'll starve to death, and then the algae can come back. Turns out, what we learned was that purple sea urchins go dormant, and they can hang out in a little crevice in a rock for years. So any new algae that starts to grow, there's an urchin right there waiting, and start munching on it and come back to life. It's not a good situation out there. But as you can imagine, once this food web starts to collapse, it radiates everything, and now it's starting to affect us. So this picture on the screen shows that in 2006, we got almost 2 million tons of sardines off the coast. And now look at 2019, just a small fraction of what we used to take. That's because the whole upwelling shut down. We're not getting that deep ocean source of nutrients that feeds the algae and everything else. No, it's still not back. This new diagram is showing that, see that block of fish that says current? What the biologists are telling us is you've got to set some sardines aside and don't catch them, don't eat them, leave them alone so they can make more sardines, and then you can fish. Well, scientists are telling us that the current level of reserve is only 1/4 of what we really need. See that bunch that says that is 4 times as large? That's what we need to leave alone in the ocean so that enough new sardines come along and we can then start to feed people with them. But if people take too many sardines, this is all predictable, here's what happens. Birds start to die because their food source is gone. Sea lions die. Whales eat 75% of the sardines that are eaten by wild animals. Look at this. 9,500 starving sea lion pups washed ashore during this blob. But it just keeps going. Remember that picture of Flatiron Rock that had that huge population of common murres? During the blob, 4 million of those birds died. This is a picture of a beach in Alaska. 62,000 birds on this one beach. So they estimate the total at 4 million that died when this ecosystem collapsed. So I'm sorry to pass on bad news, but the North Coast Journal last August put out this issue that said no sign of recovery. So the sunflower sea stars still are not back. I went to a class at the Marine Lab in Trinidad, and the biologist was saying that every once in a while somebody will find one of these in the ocean and bring it to him and say, look, they're back. And he says, not quite, because the ones you find are always small. They're immature, they're juveniles, and they don't grow up. So whatever's happening to them is still happening to them, and they're not back. Well, last month, the latest issue of North Coast Journal reported that the committee that decides these things said you can't fish for abalone for another 10 years. This is all because of the collapse of the ecosystem offshore. Okay, I'm almost finished. And before next Wednesday, you get to go home from this talk. So the big picture to end this talk is a diagram of all of the major tectonic plates around the world. And I find this really interesting. To start with, here we are. Here's home, right? And you recognize the shape there for the, what's it called? The Juan de Fuca plate. Very good. Notice that its color is imitated down by Central America. See where it says Cocos plate? These are the 2 remnants of the ancient Farallon plate. It all used to be one big thing, but now it's broken up. And you remember the reason it's broken up is that North America is moving west and ran over the subduction zone starting in Los Angeles. Okay. How about this one? 50 million years ago, the country of India was attached down here to Antarctica. It broke loose, and because the subcontinent was relatively flat and shallow, it started moving north, and boy, did it take off. The Indian plate is moving twice as fast as any of the other plates are moving around, and it was partly because it was so shallow. So it starts moving north, and when it got about in this neck of the woods, it was 66 million years ago. Anybody know what happened 66 million years ago? The what? The asteroid that killed off the dinosaurs. Before we knew about the asteroid, we knew that India had something called the Deccan basalt floods. The southern part of India is a gigantic volcano. And 66 million years ago, this lava was erupting onto the surface of the land. And it was so big, so voluminous, that scientists just knew the gases that came up from underground had to have been what killed off the dinosaurs. Well, then we found out about the asteroid and read about that asteroid. Man, that's a cool story. The asteroid definitely killed off the dinosaurs. This did not help, right? This was the 1-2 punch that did in the dinosaurs, except for birds, which of course made it through. All right, so that's an interesting story all by itself. How about this one? Why is Japan earthquake central on planet Earth? Well, here's why. So here are the islands of Japan. Look at this. North America has a little projection that covers Hokkaido, the northern island of Japan. This is Asia, and this part of Japan is on that plate. Here's the Philippine plate crashing up into southeast Japan. And sure enough, the Pacific plate is crashing in that direction. There are 4 different plates coming together. No wonder Japan has so many earthquakes. And you remember the big tsunami that wiped out their nuclear power plant? So that's their sad story, but they're used to it. And the Japanese people were always very proud of their system. They're so used to earthquakes that they're good at it. And they thought, even if a big one comes, we're going to be fine. But nature has a way of saying, you weren't ready for this one. 2004, tsunami, earthquake. This is a subduction zone. And there was no equipment on the floor of the ocean there because everybody knew it was dormant and nothing was going to happen here until 2004. Look at this. The magnitude of that earthquake was 9.1. You're on a roller coaster for 5 minutes in that kind of a problem. And that's where that enormous tsunami, look at the death toll. 250,000 people were killed in that tsunami. Well, I'm sorry to say that subduction zone is actually very similar to ours. It's 700 miles long, so is ours. You've got ocean floor diving under continental land masses. And so we don't know what the big one is going to be like. But if it's anything like what happened in Indonesia, there's a reason to make sure that your pictures are secured to the wall. Make sure that anything that can fall down and crash on you is secured, that you have a go bag, all of those things. If you haven't seen them, there's some really good pamphlets out for how to prepare for an earthquake.
And don't go to the beach to watch.
And please, yeah, we could just repeat that. Okay, that's enough bad news. I want to remind you that it's good for your head to be outside. And if you're out stomping around, it's good for your body, and those two things go together. So this is Trinidad Head, and it's a delightful trail to start down here at the parking lot. This is where the Memorial Lighthouse is, right at where that arrow is. And so you walk around there, you can identify plants because you are a creature of nature. You can get some exercise. You can't go visit here's the lighthouse. This is the platform that their house used to be on there on the left edge. There's a gate somewhere along this road that is locked and you can't go there unless...
You can go the first Saturday of every month, 10 to noon.
Very good. First Saturday of every month, 10 to noon.
It's open. Yeah, the grounds itself is open all day, sunrise to sunset. You can get to the grounds of the lighthouse, but you can't get to the lighthouse itself except for 10 to noon.
There's another gate.
There is another gate.
And if you're with a group that has permission to go there, or you're at the right time, you can actually climb the steps to the top of the lighthouse platform, and you can stand there and imagine a rogue wave that came in and crashed into that lighthouse 300 feet off the ground. It just blows me away. There's also a booklet down there with laminated pictures of the history, some of the lighthouse keepers, and some cool stories. So Trinidad is cool. That's the summary of this talk tonight. Trinidad is varied, it's interesting, it has cultural history, geology, and on Trinidad. And if you like a challenge, you would have predicted there are no coastal redwood trees on Trinidad Head. I found at least 2, maybe 3. My memory is fading. So as you walk this trail, see if you can find redwood trees. They're not supposed to be there. The reason is most of these trees are Sitka spruce that can tolerate salt spray, but redwoods don't like that. So the redwoods that survive tend to be inside the forest, maybe get a little more protection, and it's pretty high up. And maybe somebody planted them. They're not old growth like 2,000 years old, so who knows?
Blew over bird. I mean, you guys ready to find out about what Chilai Village was, so.
Yeah.
There's 1 or 2 in the section there, so.
As long as it's protected from salt spray, yeah.
I think it was like 15 years ago, we had an incredible storm that washed all the sand off the beach of Trinidad State Beach.
Oh,
I think it may have been 20 years ago. But I got a call from our neighbors, John and Larry Otis, that said, "You've got to go down to the beach right now." We got in the car and went down to the beach. And what was down there, because of the erosion of the sand, was a redwood forest. The stumps of all the old redwoods
wow.
that had subducted, and the salt had killed them, but the stumps and root system were still there.
Wow.
Hundreds of them. It was incredible.
And they were redwoods. Somebody told me they were spruce.
What's your name?
Richard,
Richard is part of the fire department. I'm talking to the people online here, part of the fire department in Trinidad, and was just describing 10 to 15 years ago, looking at Trinidad State Beach, and the sand was gone, and you could see stumps from an ancient redwood forest. That is some of the evidence that began to pile up so that we could explain how plate tectonics works.
yeah.
And so, if you were born 100 years ago, it might have been you that came up with plate tectonics theory.
Reed, that looks like where the radio towers are. Is there a reason that you have people going up to look at the cell towers?
No, when I'm leading tours up there, we don't go that far. We do the loop without the radio. Yeah. Yes.
Is any of the water and areas around Trinidad like protected areas, like marine reserves?
The coastline is packed with marine reserved areas, and there are like 10 different kinds. Can you answer that? Yeah. So
there's effort to make the north side a protected reserve, but it is not something.
What about like North Lagoon? Or like or is there not much protected?
I'm not sure where our closest marine protected reserve is.
yeah,
I think it's farther south is our closest one.
there are marine protected reserves all over the place, and in a different talk, I have a map of it, but I don't remember where they are.
So if you have national monument status, can they bring, like, I'm not opposed to wind or for it or anything, but when they bring all the structure and all the infrastructure for wind, aren't they gonna be going to a national monument?
No, not technically. The national monument is only the rocks. It's not the water.
Oh, shit.
That's that slicing and dicing thing. It turns out that the best harbor on the coast between San Francisco and Canada is Humboldt Bay. If you want to build a wind farm, if you want to build those turbines, this is the only harbor that's deep enough and no bridges to go under. And so the platform that they're in the process of starting there in the bay is not only is the harbor ideal and the only choice, like you couldn't build these towers in San Francisco Bay because you couldn't, once you build them, you can't get them under Golden Gate Bridge. So not only can we build them here, but when you go offshore, as these folks were just alluding to, the two best wind spots on the coast are just offshore from Humboldt Bay. So we could build them here, float them out there. They would be floating towers, not the kind that are anchored to the bottom. They're close to each other, and I forget the distance. It seems to me I'm remembering you could see these wind farms from the shore, so it's less than 20 miles offshore. So this is ideal, and even though Donald Trump just took away the federal money to fund those wind farms, it's such a good idea that I think it's going to stay alive anyway.
Well, it's also the federal government, the ocean was what they put them.
Yeah, they have jurisdiction of the water, but they also put leases up to lease that to companies that want to build those towers. So we'll see. It's like I was so excited when we were starting to build a high-speed rail between Los Angeles and San Francisco. Boy, did that get mired in the mud, right? Political issues. So we're going to get there. We're going to get there sooner or later with clean technology. It's just a matter of, will my hair turn gray before that?
I have to go for some kind of personal bones or something, you know.
Why are you laughing? Oh no! It happened. Well, you've done it. I want to thank you for listening. We just did a tour of the magnificent Trinidad. Thank you. Okay.